All right, so we are doing lesson 1.1, which is identifying arithmetic sequences. So this is going to bring us into our linear patterns. So our learning targets for today, we are going to be able to identify sequences that are arithmetic sequences, and we are going to be able to use the common difference to determine a specified term of an arithmetic sequence. So let's learn about what is an arithmetic sequence. So it says use toothpicks to make the following model. So stage 1, we have that one. Stage 2, we take the two corner pieces, flip them up, and then make our new square. And then the same thing happens with 3, and we just continue this pattern. So it says continue to stage 4 and stage 5. Draw your models below. I just have that drawn for us. So this is what 4 and 5 would look like. So it says complete the table for the number of toothpicks used for each stage of the models through stage 5. Well, stage 1 had 8 toothpicks. Stage 2, it had 1, 2, 3, 4, 5, 6, 7, 8, along with 9, 10, 11, 12, 13, 14. So stage 2 had 14. And stage 3 had the original 14 from stage 2, but now we're adding 1, 2, 3, 4, 5, 6 more. And so that one's going to have 20. Stage 4 is going to have the 20 toothpicks plus the 1, 2, 3, 4, 5, 6. So it's going to have 26 toothpicks. Stage 5 is going to have the 26 toothpicks along with the 1, 2, 3, 4, 5, 6 more. So that would be 32. So the number of toothpicks per stage is listed off in this table. And then it says, use the following grid to make a graph of the data in the table. So at 1, we had 8. 2, we had 14. 3, we had 20. 4, we had 26. 5, we had 32. So it says, is your graph discrete or continuous data? So remember, discrete are all those individual points, where our continuous data curves in a line. And discrete was all of our individual dots. So this is actually discrete data. And it's only discrete because we can only have whole number toothpicks. So then it says, is your graph the graph of a linear function? So remember, linear functions form a straight line, and these form a straight line, so yes. So what we actually just came up with was a sequence. So in our math notebooks, we should have this written out. It says an ordered pair of lists of numbers is called a sequence. It's just a list of numbers. What's special about our sequence is the numbers in the sequence are our terms. Okay, they're our terms. And then to refer to the nth term in the sequence, we can use either f of n, so sequence f with input n, or the index variable a sub n, and we read that a sub n. So n is the position in the sequence. So it says the toothpick data form a sequence. The number of toothpicks at each stage are called the terms in the sequence. Okay, so the numbers of toothpicks at each stage are the terms of the sequence. So what's the first 4 terms of our toothpick sequence? Well, in the a sub 1, so that's the number of toothpicks in the first stage, that was 8. A sub 2, so that's how many toothpicks in the second stage, that would be the 14. And then the third stage was the 20. Fourth stage was 26. So then it says, in a sequence, what is the distinction between a term, so 8, 14, 20, and 26 are our terms, and a term number, so what position they were in. So a term is a number in a sequence when then a term number gives the term's position in the sequence. So term number is what position they are in. The term is the actual number in that position. So doing the check for understanding. So it says for the sequence 7, -5, -3, 1, 1, what's a sub 4? So what's the term in the fourth position? That would be 1. Then the next one, it says what's a sub 5? So the term in the fifth position. So 1, 2, 3, 4, 5. That would have been 17. Now these are just sequences, but we are going to be dealing with arithmetic sequences. So an arithmetic sequence is a sequence in which the difference between terms is constant. So we're writing that out in our math notebook. An arithmetic sequence is a sequence in which the difference between terms is constant. So the difference between consecutive terms in arithmetic sequence is called the common difference. So that's the difference between consecutive terms. And we can also call that a constant difference. Consecutive just means back to back. So like 1 and 5 are consecutive. 5 and 9 are consecutive because they come back to back. So it says, explain why the toothpick sequence is an arithmetic sequence. Well, we had a constant difference. Each new stage, we added 6. So had a common difference of 6. So it's an arithmetic sequence. Scrolling down. So then it's asking for the rate of change, and it's going to need to load. What's the rate of change for the toothpick data? So remember, rate of change, slope, it's how much it's changing by each time. That would also be 6. So 11a says, look back at the graph in item 4, determine the slope between any 2 points on the line. Well, we increased our toothpicks by 6 for every 1 increase in stage. So the slope was 6. Then it says, describe the connections between the slope, rate of change, and the common difference. Well, they're all 6. They are all the same. And that's going to be the case for all of my arithmetic sequences. My common difference, my rate of change, how it's changing by each increase, and my slope are all going to be the same. So let's do the check for understanding. So it says, tell whether each sequence is an arithmetic sequence. For each arithmetic sequence, find the common difference. If you want to pause the video here and see if you can do it on your own, that would be awesome. If not, just follow along with me. So the first one I have is 9, 16, 23, 30, 37. Between each new term, we're going up by 7. So yes, this is arithmetic. And the common difference, let's go CD, is 7. Then this one we have -24, -20, so that goes up by 4. But then we go up by 6 to get from -20 to -14. So no, this is not an arithmetic sequence. There's not a common difference. Okay, now at 14 we get -2.8, then -2.2. So that's going up by 6/10. And then from -2.2 to -1.6, that again is going up by 6/10. And then the same thing. So yes, this is an arithmetic sequence, and our common difference is 6/10. 15, we go 3 to 5, so that's 4, and then 5 to 8, that's 3, and then 8 to 12, that's 4. So that is not a common difference, so no. 16, we go 1/4 to 1/2, so we add a half. Then we go from 1/2 to 3/4, so we add a half again. Not a half, a fourth. And then 3/4 to 1, that's adding a fourth again. So yes, this is an arithmetic sequence. So CD is 1/4. And it says, can the common difference in an arithmetic sequence be negative? If so, give an example. If not, explain why not. So yeah, it can be. We can be going down. We can be adding a negative. So an example, what if we had -8, -10, -12, -14? Each time we're going down by 2, so my common difference would be negative. Your practice is the 11.1 practice. Let me know if you have any questions.